Welcome to the North American IPv6 Summit 2014. Thank you for joining us here in person in beautiful Denver, Colorado, and on the webcast from around the world. My name is Augie Mitev. I'm the chair of the Rocky Mountain V6 Task Force. First, I want to say a few words about the Rocky Mountain V6 Task Force, the organization behind this event. We are a group of volunteers passionate about IPv6. Our mission is to support the adoption of IPv6 and to help educate the community on IPv6 related technologies. This year we worked closely with the other North American IPv6 task forces. This is our 7th annual event. The theme for this year is putting IPv6 to work. This is our best event ever. We have a great speaker lineup. Thank you, Dan Thorbett. Our keynote speakers are Tom Coffeen and Richard Jimerson. We have great presentations from BC Hydro, PowerTech Labs, and Wells Fargo. This event is being recorded. All the sessions will be available on our virtual platform on the internet after September 29th. You will receive an email with your logging information. We have a wireless network up and running. We're broadcasting 2 SSIDs, NA IPv6 CenturyLink Duo and NA IPv6 CenturyLink IPv6 only. Thank you, Tim Martin, for your help. The agenda for today and tomorrow: the general sessions will be in this room in the mornings, and in the afternoons we have 3 different tracks: SDN, IPv6 security, and IP addressing. For those of you that we are here on the 38th floor, and to go down to the 2nd floor, you're going to have to go down on the elevator all the way down, and then circle around and get on a different elevator to go to the 2nd floor. Just a heads up. You're welcome to participate in our passport program. You can punch your cards with our exhibitors and make sure to return the cards back to registration to enter to win some cool prizes. We're going to be giving those away tomorrow at noon. Throughout the day we have breakfast, coffee breaks, lunch. Special thank you to our sponsors. Without their generosity, we wouldn't have this event. Thank you. Okay, and then probably the most fun part is the beer and gear event at 6 o'clock here in the exhibitors areas. It's noon today. We're going to announce the best IPv6 product and best IPv6 service. We're doing this for the first time. We're very excited about it. And we're also doing certification testing for those of you that have pre-registered. This is happening on the 2nd floor today between 1 and 3 p.m. We worked hard to put this event together. We hope you enjoy your time with us in the next 2 days. Thank you. Our keynote for today is Tom Coffeen. Tom. Okay, I'm going to read this. Tom Coffeen is the Chief IPv6 Evangelist at InfoBlox, the market leader in DNS, DHCP, and IP address management, and network solutions. In InfoBlox, Tom is focused on the articulation of effective IPv6 adoption strategies as well as IPv6 adoption trends for customers, potential customers, and public media. Prior to joining InfoBlox, Tom was the Vice President of Network Architecture at the global CDN Limelight networks, where he led their deployment of IPv6. Tom brings 16 years of network engineering and architecture experience to his role at InfoBlox.
Thank you. Thank you. Thank you. From the beginning, cool. All right, good morning, everyone. We've got a tremendous view here at the 38th floor. I accidentally got off the second floor yesterday, and there was a sign for a conference, and the phrase abusive head trauma was on the sign. Did anyone else see that? Is anyone here for the abusive head trauma conference? If so, I think you need to be down on the second floor. So I'm super excited to be here giving the keynote today for the Rocky Mountain V6 Task Force Summit. This is the third year that I presented, and every year the event seems to get better and better. And of course, we seem to make more and more progress on the front of IPv6, and that's undeniably a good thing. I want to thank the folks that put this together. They do a lot of hard work in making sure this all comes together, and a lot of it's behind the scenes and underappreciated. And Augie, of course, mentioned it. He didn't mention that he pulled an all-nighter a couple nights ago, making sure that the network got stood up properly. And of course, Dan Torbett for getting all the speakers lined up, Terry Kotcher and Karen Wircher, and who am I leaving out? Scott Hogue, of course, who is a little more in the background this year, but still very much instrumental to making this a successful event. And of course, the company that I work for, InfoBlox, a diamond sponsor at this event, as we heard. Very excited and happy about that. There's a lot of really high-powered IPv6 folks in the room, so it's quite an honor to be up here giving a keynote. And I try not to concentrate on the fact that my company is the diamond sponsor and that the keynote slot might have something to do with that. Like the old joke about the unattractive baby with the pork chop around its neck so the dog will play with it. I don't know if has anyone heard that? So hopefully the baby isn't too ugly and the pork chop is delicious. So this year's summit theme, putting IPv6 to work, it's an exciting one, and I think it's earned, right? So we're finally starting to see some IPv6 adoption in serious enough numbers where I can boldly assert in my presentation, IPv6 has arrived. So where are we and what's next? One thing that I'll add at the beginning here before I get started is that, just so I don't forget at the end, we put together a worksheet for IPv6 address planning that myself and Scott Hogue and Ed Horley are happy to work with folks one-on-one. Everyone should have gotten a worksheet in their bag, so feel free to use that on your own if it's helpful, and if you have an opportunity to interface with myself or Scott or Ed on your own IPv6 address plan, we'd look forward to doing that. So I was hoping to remember to say that at the end of the presentation. Maybe I will and repeat myself, but I just wanted to get that out there first. And of course, we've got a stellar group of speakers. Part of my presentation will be talking about some of the things that I'm excited to see here this year, and also some of the themes around the presentations that are going to be important to the overall theme of this keynote. And I'm going to try to keep things on the relatively short side as we go through this, give some time back to the schedule. So with such a bold assertion as IPv6 has arrived, I'm gonna try to screw things up for myself right away and take a poll, an informal poll here, and see who here agrees with the statement, and with qualifications maybe, that IPv6 has in some sense arrived. That's pretty good. Okay, good. I'm not in too much trouble. So the folks that didn't raise your hand, we won't single you out, but the folks that did raise your hand, if you guys break into any arguments, please take it outside. I'm going to talk about the two ways in which I think that we can talk about IPv6 having arrived. And the first way I'm going to talk about it has to do with the statistics that we've seen over the last year, and I think a lot of us in the room are already familiar with those. But we'll review those to sort of get a sense of where IPv6 is and the fact that we've attained a kind of critical mass around IPv6 adoption that makes us confident to say that it's arrived. The second way in which I'll describe IPv6 having arrived is a little more subtle and intuitive, and we'll have an example from the popular culture to sort of drive that point home. Then I'm going to talk about some critical themes about where we're at with IPv6 and what's going to be next, what we need to be focused on as we go forward with the level of IPv6 adoption that we're seeing. So it wouldn't be an IPv6 conference without this slide from Dr. Houston, right? Happy to be able to put it up there first before anyone else. Of course, we're getting close to where we can retire this slide, right? So we've got 4 of the 5 rears that are down to their last, below their last /8 of address space, including the 3 rears where we have the most growth in the internet. You may have heard earlier this month that IANA, through reclaiming efforts and checking the couch cushions, found some /12s of IPv4 space to hand out. Right, so there's a little bit of a blip in the radar in terms of additional IPv4 space. Of course, anyone in this room will be happy to tell you that that's not something to think will save you from the inevitability of adopting IPv6, but we'll throw it out there in relation to IPv4 Run Out. And of course, there's still a gray market for IPv4. If you want to go buy some public routable IPv4 addresses, you can do that. Last time I checked, the prices were still around $10 to $12 an address. Is that still a serviceable price? Is that pretty much where things are at? $10 an address, $12 an address, around there? Anybody know? Yeah, I'm not really sure, but I think the point of conferences like this is that we don't want to have to find that out. We don't want to actually have to go out and price IPv4, and that's the point of adopting IPv6. But very clearly, IPv4 finished. So let's look at some key U.S. network operator measurements. And this is really where we start to get a sense that IPv6 has in some sense reached critical mass. Verizon's traffic is up above 50% for IPv6. Comcast is above 30%. And we see that it may be hard to tell from the graph. I don't know if you can see the x-axis, but this is actually happening. You can see Comcast traffic increasing nearly 30% in the last year to year and a half. You can see Verizon's traffic doubling in a little over a year to 54%. And even those providers that got a somewhat late start by comparison, right? AT&T and Time Warner Cable. AT&T's IPv6 traffic has doubled and now over 21%. And we see Time Warner at 10%, but growing. The trend is clear looking at these graphs, right? The levels of IPv6 traffic among network operators continues to grow. We've seen some academic research lately that showed that we're looking at around maybe 3.2% of websites being available over IPv6. But if you look at the top 100 Alexa sites, you've got 55 of those have authoritative IPv6 DNS servers. So more than half. And even though you see a little bit of a dip there in the upper right-hand corner, the trend is pretty clear. And of course, we're all familiar with this graph. 4.3% global IPv6 traffic hitting Google. I was I had an exchange with Sylvia Hagen recently, and she told me that she did some calculations based on the growth rate shown in this graph. And based on that growth rate, she was anticipating that we'd be somewhere around 50% within 3 years. And here are the levels of IPv6 hitting Google here in the US. So this should be a message to enterprise IT managers and marketing folks at enterprises. 1 out of 10 users out there on the internet here in the US might have trouble accessing your website, or might have more trouble accessing your website than your competitor's website if it's not available over IPv6. And we could have some academic debates about whether those kinds of delays are really going to matter, where you've got a session being initiated from IPv4 and having to be translated to IPv6, or rather vice versa. If I've got an IPv6 client and I'm trying to access an IPv4 only website, we know that 250 millisecond delay is enough to drive users to your competition, degrade their user experience on your website, and make them think that your website's not ready for prime time. So rather than have those academic debates at an enterprise, isn't it just easier to stand up your website on IPv6 and make it available over IPv6? I think it is. I mean, it's never been easier than it is now in terms of having hosting services and CDNs that support IPv6 today. So getting some or all of your web content over IPv6 is pretty easy to do. So with 9.6% of users in the US accessing Google over IPv6, we can actually calculate the number of people that is. So with the US population of 323 million, US internet penetration, pretty high, 70%. So that's 232 million internet users, with 9.6% of those being on IPv6. That's 7% of the overall US population. 22.3 million IPv6 users. 22.3 million IPv6 users. It's pretty impressive. With IPv6, we like to do a lot of comparisons between values, right? Because of the ridiculous size of the IPv6 space. So we'll do the same thing here, even though it's a much smaller number and more manageable. Get some sense of how many people 22.3 million people is. So that's more people than the 7 most populous US cities combined that are running on IPv6. That's 17 times more people than the total number of Freemasons in the US. That's information to keep handy for your next social gathering. And that's 230 times more people than subscribers needed to make Sarah Palin's streaming TV show profitable. So it should hopefully give you some idea of how many people 22.3 million people is that have IPv6 today. So those are some data, hopefully bolstering the case that IPv6 has, in the more concrete sense, arrived. But the other argument for the arrival of IPv6 is maybe a bit more abstract and has to do with a certain sort of zeitgeist, to use a word to take advantage of my liberal arts education. The German word meaning time soul, and sort of the feeling or spirit of the time. And with that in mind, I think here's the best evidence that we have that IPv6 is officially here. And that's not it. Not John Kern's presentation from last year.
We invented another version which has 128 bits of address in it. That's, okay. I'll do the math. It's 3.3.
Hold on a second. Go ahead.
That's right, you're right.
Yeah,
3.4 times 10 to the 38. That's right. That's very good.
Very good.
Could everyone hear that? So Dr. Vint Cerf on the Colbert Report. I mean, if that isn't talking about the size of the IPv6 address space, if that's not evidence that IPv6 is here, then I'm not really sure what is, beyond the data that we've seen, obviously. So even with all this progress with IPv6, internal enterprise adoption of IPv6, it's a bugbear for us at InfoBlox. Most of our customers are enterprises, and we're constantly browbeating them into adopting IPv6, and some of them have and some of them haven't. But it continues to be a work in progress. And I pulled up this slide from John Curran's keynote from last year because he had an interesting victory condition, and I think it's pretty valid. I think it's pretty relevant in terms of one of the areas, again, where IPv6 just seems to be slow to be adopted. Leading companies, for example, Fortune 500, using IPv6 for their internal networks and desktop office wireless devices. So this would be a victory condition, proving that IPv6 adoption has, really reached critical mass. And I don't know that it's really possible to tell where we're at with enterprises. I mean, I have a lot of anecdotal information from customers that I work with, and we know large enterprises that are adopting IPv6 internally. But there's just not a whole lot of sharing going on related to their operational experiences, sharing with other enterprises that might be in their vertical or in other industries. And this is a challenge. It's a problem. We don't have good data on where enterprises are at, and we don't have a good operational record of some of the challenges that they're running into. We can infer a lot of those challenges based on what we see with IPv6 in dual stack environments, but it's hard to know. We can look at publicly available data and get maybe a little clearer of a picture. We did a really simple survey looking at the Forbes 2000 and based on whether or not a company had a routed IPv6 allocation, whether or not they had an IPv6 website, an IPv6 name or mail server. We got some percentages in terms of the top 36 US companies of the Forbes 2000 list. So out of those top 36 US companies, this was sort of the percentages that we saw for these IPv6 adoption attributes. And if you looked at it by, and hopefully this is, yeah, it looks like it's readable. If you look at it by the verticals that these enterprises occupy, you've got the 12 major verticals here. 7 of the 12 major enterprise network verticals, or enterprise verticals rather, have a 50% adoption rate according to the data that we looked at. So it's not nothing. I mean, there's definitely some evidence that enterprises are making plans to adopt IPv6. But again, we need more data, and we need more information from the enterprise community, a willingness to share their operational experiences. And some of that's trickling out, but we could always use more. So. Enterprises that don't adopt IPv6, of course, we've been making this argument for years, that they're going to face uncertain risks and costs. And there are certain ways in which they're already running IPv6, of course not being aware of it. And that's introducing security issues that for them, and if they try to disable it internally, they find out that they're out of scope for support with Microsoft pretty quickly. So this is a challenge, and it's going to continue to be a challenge for enterprises. I want to talk about some more subtle costs related to enterprise adoption of IPv6 or failure to adopt IPv6, and related to their use of cloud services. So something that's somewhat axiomatic to the argument I'll be making is that it has to do with what happens to a network operator when they run a dual stack network over time. So if I go ahead and if I'm a service provider and I'm running dual stack today, and I've been running dual stack for a while, something happens in the process of me looking at the cost of running that dual stack network, and I start to get an itch to do something. And what is that? Anybody know? Shout out the answer. Is get IPv4 off the network? Yeah. It's expensive and challenging to run a dual stack network over time, right? Initially, you need to do it to avoid the risks and costs of not adopting IPv6 at all. But once it's up and running, over time, you see the organizations that have adopted the earliest and the businesses that have adopted the earliest are looking for ways to reduce the amount of exposure they have to IPv4. And so cloud services aren't going to be any different in this regard. Since we're talking about a service provider, essentially, with cloud offerings, we're talking about companies who see their products commoditized often, razor-thin margins. Anything that they can do to preserve, to basically save money on operational costs, they're going to be looking to do that. And if that means that running IPv4 as a legacy protocol and charging customers extra for that legacy protocol, then that's what they'll do. And they'll pass that extra cost of operating an IPv4, a dual stack network with IPv4 on to the customer. So this is the NIST definition of cloud, and I just threw it up there so that we're kind of all on the same page. I think it's a nice, tidy, and elegant sort of description of what we're talking about when we talk about cloud, and of course the characteristics of cloud networks. So if we talk about what it means in terms of benefit to a cloud provider to run IPv6 internally, unlimited scale, operational simplicity, and management efficiency. If we're looking at software as a service, you could basically have all of that be IPv6 only internally, and then the interface that's facing the customer, you know, you might have a translated interface, but that's an externality as far as the cost goes. So vendor-only infrastructure with a browser, a thin client, or an app that's accessing the cloud. But any dual-stack infrastructure OpEx cost will eventually be passed on to the consumer that's consuming this cloud service. So if you look at some of the other models of cloud, platform as a service or infrastructure as a service, again, the interface moves a little bit, right? So platform as a service, we see applications and data on the customer side. They could be IPv4. The cloud provider could provide that IPv6 to IPv4 interface and run IPv6 internally. But again, if there's any sort of accommodation for dual stack over time, that's going to translate into higher costs for the purchaser of the cloud service. And the same is true for infrastructure as a service potentially. IPv4 components require additional provisioning management practice that introduces friction and cost, and that cost gets passed on to the consumer. So anticipate premium pricing for IPv4 legacy protocol components. And that leads us to the next element of my discussion on the economic benefit of IPv6 related to the Internet of Things. So here's a quote talking about the potential value of IoT. So the way I understand this quote is that there's tremendous business value that's locked up in the telemetry of stuff that's on the network, stuff that could be potentially connected to the network, stuff that you wouldn't imagine could ever be connected to the network. The ability to have that stuff be able to talk to the network and relate its condition, its location, its function, its overall state. It's pretty easy to see that that kind of data would potentially create a flood of new products and services, a new way to manage the network and manage the enterprise, whatever the organization is, take advantage of that business data to really streamline operations across all levels of the organization. But of course, the precondition for accessing that data is getting all those things online. And that's the basic scale challenge of IoT, right? Billions of devices. And we've seen different numbers related to the number of things that we're going to see coming online over the next few years. And you know, a lot of the devices that we talk about are going to be mobile devices for folks just using to access the internet. But where the Internet of Things is concerned, you know, we talk about scaling to 20 or 50 billion devices in the next 6 years. You know, a lot of those devices are going to be things, very simple, small devices with a very basic, you know, rudimentary network stack. So regardless of whether we're talking about, you know, in this case equaling 1 or 2.6 or 5, we're just talking about a whole lot of devices that we're going to need IPv6 to address. But this introduces another challenge in that I don't think it's really clear yet what the engineering to bring those devices online looks like. I think we're struggling maybe to understand what standardization is going to look like in an Internet of Things environment. If we start to look at that particular problem and we start to think about cloud and SDN along with it, and anybody that's playing buzzword bingo in the audience, that should have basically given you a winning card at this point. If I say BYOD and mobile, then we're good, right? But I think you can start to see the basic outline of a new model for next generation networking where you've got an Internet of Things that's producing data through telemetry that can then be fed into a cloud environment and processed. At some point, that data is going to be used to program the network. Okay, we're not there yet, right? We've still got a lot of the old rigid networking protocols that that we know and love, but that preclude the ability to really do things in real time and have like flexible flow programming that is responding to the data that we're getting from the network. And so if you flash forward 10 or 20 years, and I don't know what the time frame on this is, but I think you can start to see the outline of what this looks like, where you could have this environment where the data that's coming from all the devices that are connected to the network being processed by the cloud and being used to reprogram the network in real time creates tremendous, unprecedented business agility that we really haven't seen, that we've hoped that we would get out of our networks, but that really hasn't been available to this point because of the rigidity of the existing protocols. So this is kind of pie in the sky stuff, and it's more than an excuse, though, to just talk about three buzzwords that we're hearing a lot today: Internet of Things, cloud, and SDN. It's really a clarion call to say that, even though we've arrived at some level of IPv6 adoption today that we can say, hey, good job, we've made significant progress, there's a certain amount of standardization of operation that's going to have to take place. Obviously, running a bunch of dual stack networks to connect IoT to cloud and back into SDN is going to be problematic, right? There's too many inefficiencies in that model. Too many interfaces, too many rat hole gateways that will prevent the ability to operate those networks in a way that's cost effective and that produces the kind of results that we'd like to see. So we really need standardization of IoT, of cloud, and SDN around IPv6. And we're going to hope for the best commitment and participation from the standards bodies that are helping us really get the protocol right at the protocol level. But on the operations side, it's really up to the folks in this room going forward to understand what operational standardization means and what it's going to look like. And I don't think we necessarily know that answer today, but it's something that we're going to learn as we go forward. And it speaks very directly to something that my colleague Ed Horley pointed out in a recent article in Information Week related to a skills crisis in IPv6. If we're going to get to the Shangri-La of unleashing business agility through the connection of IoT, SDN, and cloud, do we really have the IPv6 skill set to manage IPv6 networks in a way to make this happen? So a quick poll: how many people in the audience feel like they have the experience and skills they need to effectively manage IPv6 today? That's pretty telling, right? So that's really sort of an antithesis to the idea that IPv6 has arrived and the central thrust of my presentation. A lot of tentativeness on the answer of whether or not you feel like you have the skills and knowledge that you need to effectively manage an IPv6 networks. And of course, to manage IPv6 networks. Of course, the protocol itself creates headaches. And we're aware of that. I'll have something to say about that in a moment. But if you're looking for a big keynote-y type theme out of this presentation, this is it. Putting IPv6 to work, I think it's a great theme for the conference. Going forward, to be able to continue to put IPv6 to work, we're really going to need to see a standardization of IPv6 operational practice. And to get there, we're really going to need to address the skills crisis. so that when I ask the question, how many people in the audience feel like they have the skills and the knowledge and the experience with IPv6 that they need to run those networks, all the hands shoot up. We're lucky, right? Sometimes IPv6 just works. And that's not to take away from the years of effort that many people in this room working at vendors and in the IETF have put into it, right? So, I mean, the reason that it just works is because a lot of the painful groundwork has already been laid, and the territory fought over and claimed. But tweets like this put a smile on our face for obvious reasons. Other times, but you have to remember that IPv6 never had to be the best choice, right? And sometimes we curse and say that it's definitely not the best choice. IPv6 only had to be better than the next worst choice, right? So, and this is the same criterion that thankfully my wife used when selecting a mate. But this is another sense in which IPv6 has arrived. There's been a lot of inaction on IPv6 in the past because folks were sitting on the sidelines waiting for a perfect protocol. They were waiting for IPv6 to be the magic bullet, the killer app that was going to induce everyone to put IPv6 on the network, and then IPv6 is going to work perfectly. And in the absence of that scenario, we just wait. No action on IPv6. Well, there's too many problems with it. It's too many unknowns. Too much about it that's difficult to work with. And agreed. I mean, there's definitely turbulence there when you get into running an IPv6 network. Some things are easier than you might expect. Some things are much more difficult than you would have ever anticipated. But a lot of the folks that were sitting on the sideline, looking at the data we're looking at today with IPv6 adoption, it's getting very difficult for them to continue to maintain that perspective and that distance from IPv6. It's not a perfect protocol, but it's the one that we have, and it's the one that we're going forward with, and that's obvious from all the statistics that we're seeing related to IPv6 adoption. So we don't necessarily have perfect control over how the protocol behaves, right? There's still a lot of kinks that are being worked out. We're seeing how things are behaving in the wild or not behaving, and that's challenging. But we do have control over operational experience. We do have control over the standardization of our own operational experience and effort, and that's definitely something that we can focus on in the absence of a particular feature in IPv6 not working in the way that we want it to work. So for that reason, developing that standardized operational knowledge, conferences like this are critically important. When I look at the list of topics that are being covered and the degree and intensity of expertise and knowledge that's being presented, it's tremendously exciting. I think we're on the right track. And as much as we all sort of realize that IPv6 percolates a little bit below the surface for a lot of IT folks and network folks, I hope that there will continue to be a focus on events like this to really bring that critical knowledge to bear on standardizing IPv6 operations. So with that in mind, I just really want to do a brief review of some of the presentations that we're looking at today, and maybe you can keep in mind some themes related to these presentations in the context of that operational IPv6 standardization. So IoT IPv6 practice, I'm looking forward to success and future of IPv6 from an electrical utility perspective. Some of the themes here that I'm hoping to learn about, the standardization of IoT, right? Because there's some challenges with IoT related to the lack of standardization, right? So there's some IoT solutions out there that are just getting purchased by IT, and you see sort of the same problem that you see with cloud, where you end up with sort of shadow IT. One silo in the organization will buy an IoT solution and they'll deploy it, and they won't know how to interface it with the IT network properly, or they won't interface it with the IT network at all. Something inevitably breaks or doesn't work right, and then they go to IT and they say, hey, we bought the solution, can you fix it for us? And then IT looks at it and says, well, this is totally not standard, and they have a big fat manual related to an IoT solution that's something that they're going to learn once and use once for that deployment and never use again. So that's not operational efficiency, right? So standardization of IoT is critically important, and it's going to be a subject that comes up again and again as we labor to get these 20 to 50 billion devices online. I'm hoping to see some of that in the presentation. Oh, enterprise, again. I'm going to commiserate with you on enterprise and the challenges of enterprises running IPv6 internally. We talked already about the Windows challenge, right? So, you know, a lot of folks like, well, you got the security problem because you've got IPv6 running on your network and you don't know about it and you're not looking at it. So, okay, well, we'll just go in and turn it off. Well, now you're out of scope. Microsoft isn't going to support your Windows boxes because they're relying on it. They basically have tested all of their functionality in an IPv6 enabled environment. So this is a challenge. Enterprises are slowly coming around to solving it in different ways. But the pain points that they're running into are related very much to that problem of a dual stack network, running a dual stack network effectively when some of the protocol elements, you know, are kind of there, mostly there, but they don't necessarily have the hooks related to managing devices in the way that enterprises like to manage their networks. So if I have a host that has both an IPv4 and an IPv6 address, it should be trivial to just manage that device as an object on the network and identify that it has IPv4 and IPv6 addresses and effectively manage it. But that's actually beguilingly difficult to do, and we need better solutions for that. And I definitely sympathize with enterprises who are calling for that. So DHCP in mixed environments, right? DHCP v4, DHCP v6. We're definitely seeing some variance in behaviors there depending on the clients, depending on the DHCP server that you happen to be running. This is a challenge. Even something that should be as simple as doing dynamic DNS for IPv4 and IPv6 can introduce problems. We're seeing some progress on that front, but probably not happening quickly enough. So rather. So I'm looking forward to learning about Wells Fargo's IPv6 journey and seeing some of the issues that they've run into and hopefully taking that wisdom and feeding it back into the enterprise community. I don't know what to expect from this municipal IPv6 case study. I don't know enough about wireless and IPv6, and I want to learn more, so I'm really going to be paying attention to this presentation, trying to learn what the themes are related to operating v6 in a wireless environment. And IPv6 cloud and SDN practice, two presentations focused on here. OpenFlow and IPv6 by RMv6TF, very own Scott Hogue, and I can't pronounce Chip's last name. I'm not even going to try. Dr. Chip will be presenting on IPv6 SDN and OpenStack. He's been doing some really great things at NEFOS with it, and I'm looking forward to hearing more about it. And we talked a little bit about the themes related to cloud and SDN, and I hope to see some more exploration of what that translates into operationally from those presentations. And then very much looking forward to Christian from VMware. He's doing a presentation on lab as a service, the easy way to hands-on training. And of course, this is great. I mean, the faster you can stand up a lab and start to play with IPv6, the better off you are. You know, if you've got equipment lying around that you can cobble together to do a v6 lab, that's great, but not everyone's in that position where it's easy to come by actual physical hardware that they can cable up and play with IPv6 on. So looking forward to seeing how easy it will be to do labs with IPv6 based on this presentation. Training, and more training, right? So again, the skills gap, this education gap related to IPv6. Myself and Ed Horley and Scott Hogue are going to be trying to find time to help walk through IPv6 address planning worksheets in case anyone's interested in doing that. Looking forward to chatting with folks about what their IPv6 address planning experiences are and hopefully helping them move forward with that. And on that note, I'm going to do a shameless plug of my book for O'Reilly that's coming out. The actual print edition will be out November 15th. The early release edition's out now. So if you want more information on IPv6 address planning, then it's one place to get it. And that's all I had. I'd like to hear any questions that folks have, or maybe have a wild and woolly discussion, disagreement, or or not. Maybe nothing I said was controversial. Or any questions? Yes. So aside from the obvious IPv4 depletion problem, what are some of the business cases that we're using to sell to like basically the CIO level and the IT director level? Well, I think I talked about a big one today, right? I mean, and again, it's not something that's going to happen in the next 4 quarters. So you have to have a CIO that, and I think a lot of CIOs are there already, right? I mean, they've seen tremendous disruption in terms of how they consume IT services based on what's happening with cloud. And so it's pretty easy to get them, since they've got over that hump, it's pretty easy to get them over the next hump, which is to say, look, if you ever want the super duper business agility that's locked into the things that are on the network now, or rather not things that are on the network, but things that are in the business now that could be potentially connected to the network, you have to get to IPv6. You just don't have the addresses to do it on IPv4. You know, NAT's not going to cut it. You can't address things with IPv4 and just build tunnels everywhere. Operationally, it's not something that scales. So I find that compelling. I don't know. If I'm a CEO, I think it's compelling, but everyone's mileage may vary in that regard. If that doesn't work, I mean, you can just point at the graphs. Look at this graph. Like, what part of this don't you understand? That just up and to the right, that the message is there, right? Sure. Yeah, I don't know. I mean, so are there more specific examples other than depletion and say a more abstract case related to what the networks are going to look like in 5 to 10 years? We talked about one related to getting your website online over IPv6. It's sort of I think for some IT folks that are committed to doing IPv6, it's a bit of a Trojan horse, right? I mean, you get IPv6 turned up on a website, and by the time you get to the point where you're able to do that, you've already onboarded quite a bit of IPv6 knowledge and training and expertise, and potentially competitive advantage that you can point to say, look, you don't have to. There's a risk when you've got a v6 client and they're connecting over, IPv6 to an IPv4 only website, and you can point to that number. It's like 22.3 million IPv6 users in the U.S. 1 out of 10 folks. That's a risk, right? I mean, if my competitor's website's available over IPv6 and mine isn't, there could be that variance that causes them to be like, well, that website's not doing what I needed to do. I'm going to check out what their competitors are up to. I think that's pretty compelling. Again, mileage varies, and CIOs are all over the map in terms of their perspicacity. Any other questions? All right, well, thanks so much for your attention this morning, and I look forward to interacting with everyone during the rest of the conference. Thanks again.